Welcome back from spring break, guys. I hope you enjoyed it. We're going to dive right into Chapter 12 here, and Chapter 12 deals with life insurance. Now, life insurance companies can assume the risk of paying the face value of what a policy has because they don't expect that many people to die. And so the return of that premium paid by the policy holder does not normally go out as often as they're taking that risk. Unfortunately, with the COVID crisis that's going on, a lot of life insurance policies are unfortunately being used, and so it didn't follow the norm. And this is what insurance companies are looking at, is what normally happens. And so they can assume the risk because in likelihood, not many 40, 50-year-old people die suddenly, okay? And so they can assume to take out these large policies and say they're going to pay them because not that many people have to use it. So they assume the risk of doing this, okay? And that's why when you take out a life insurance policy, the annual rate for a 30-year-old person is a lot less than what it would be for a 60-year-old person. Okay, the term beneficiary is the person or person's name to receive the proceeds from a life insurance policy. Okay, and so that is what beneficiary means. Now, insurance companies, how do they base their premium? How do they base that yearly expense that a person will assume for insurance? And the first one is simply looking at the statistics, okay? What is the prediction of how many policyholders of a certain age will die in the next few years? Now, they're looking not at an individual person, they're looking at a large group. So they're looking at statistics, okay? Now, they're also looking at the company expenses. How much for that year, in the next couple years, do they have to, what kind of expenses will they have to take out? That would be what they're renting their building for, the electrical and policy expenses that would go out. So they're looking at all their expenses. The last one they're looking at is what is their investment? What is going to be the returns on their investments in stocks and bonds and other securities? This is actually, they invest their money to help lower the cost for the premiums for their people. So they're going to take all three of these things and look at over, and then they're going to set their premiums for that year and the next following years. Okay. Now, looking at number one, remember we talked about the statistic predictions. How do they make that? Well, they use a CSO. And a CSO stands for the Commission Standard Ordinary Mortality Rate Table. Okay, and so this is looking at data over the years of groups of people of a certain age. Okay, it's not looking at one individual, it's looking at a whole entire group. And this tool is what the insurance company used to help predict the number of deaths within a certain group by a certain age. Okay, and so it's collected data over a number of years. Now, that doesn't mean that it's going to happen. Only God knows when your time is up. But they're looking at a large group, and so they can make a good estimation of how many people would happen. Unfortunately, they can't predict an epidemic like COVID, and so their numbers for this year are going to be very out of the norm, okay? And so they're looking at what is the standard. Okay, now we are going to use this equation. Probability equals the amount of deaths at a certain age over the amount of people living at a certain age. That's going to help us predict the probability of a given age of when a person could die. Okay, and so this is the equation we're going to be using for all of it. We're also going to be using the table 12.1 on page 447. Now this table is based on 100,000 people. Okay, so we've got to remember that when we're looking at the table. I'm going to pull up this table a minute here and show you Remember, it's on page 447. There's a few things that are going to be really important that we're looking at. First of all, this table is dealing with men, okay? If you notice, it says 2001 mortality table for males, okay? So we're only looking at males. And it starts at age 17, and it goes all the way up through age 67. So we're looking at the numbers that are bold print. So these are the ages. It's broken down into columns. The living, number of living. Remember, this is out of 100,000 people. The number of dying at a certain age. The death rate. And then the expectancy of years. Now, this expectancy of years is in addition to the age. So this would be like 17 plus 61. Okay, of when to expect. So that would be at age 78. Okay, and so these are the table that we will be using all throughout our lesson. Okay, so get comfortable with using that. Okay, let's go ahead and we're going to look at some of the examples to see how do we go ahead and use this. Okay, so the first thing is just to get comfortable with our equation. It says, what is the probability that a male child will die within the first year of life if L, that's living, expectancy is 100,000 and the death is 97. Normally we'd go and look at our chart on 447, but remember our chart starts at age 17. This is asking for the first year of life. So we got to go ahead and use the information that they gave us in the assignment here. And so we're going to use our equation. Our equation, remember, is the probability of dying. And sometimes they use the abbreviation QO. And here's our equation. Number living over the, number dying over the number living. So remember, we're talking about first year of life, so we're talking about age 0, okay? And we've got to go ahead and use the information. So the amount dying at year 0 was 97. That would go in the numerator. And the amount of living would be 100,000. Now, all I'm going to go ahead is take the top, and I'm going to go ahead and divide it by the 100,000. And I get this decimal, okay? It is a very small chance of a male baby dying within the first year of life, okay? We'd go ahead and then move our decimal 2 to the right if we wanted a percent, and the percent would be 0.097%. Okay, so let's go ahead now and use our get comfortable using our chart here. Okay, so we're going to use this example here. What is the probability that an 18-year-old man will live to age 50? Out of 100,000 men whose age is 18, how many will still be alive at age 50? Okay, so you've got to use your table on 447, and we're going to use our equation here. I'm going to show it all to you just to make it easy here. Okay, so here's our equation. Probability of the death of who will still be living basically at 50 and out of the age 18. So we're going to use our chart, and looking back we're going to look at age 50, and we find that the amount of number of living, because they're asking, what are they asking? They're not asking about death. They're asking for how many will be alive. That's why we have the L here, okay? And so we're going to look in our table to the L living. So go to the column where it says L. And we find at age 50, there's 94,344 living still at age 50. Now, we're comparing this out of 18-year-olds. So in our denominator, we're going to find how many are still living at age 18. And going to the chart, we see that it's 99,260. Go ahead and divide that out, and then turn it to a percent, which is 95%. Okay, we're not done, because the next part says, out of 1,000 men whose age is 18, how many will still be alive at 50? They don't want to know the percent. They want to know how many actual physical human being men will be alive. So we're going to go ahead and take our percent and multiply it by how many people they have. And they told us 1,000 men. So we're going to work with our percent. Remember, we've got to put it in decimal form again to work with it. So 0.95 times 1,000. And we find that 95% of those 1,000 is 950 men will still be alive. So be careful with the problems. Make sure you're paying attention to what they are asking. Okay, let's do another example. Take a look at what they're asking here. What is the probability that an 18-year-old man will die? Okay, so we're not talking about living, we're talking about dying before reaching age 50. Out of 1,000 18-year-old men, how many will die before the age of age 50? So with our equation, we're using our probability again. We're taking the number dying between 18 and 50. Okay, so we're looking at over a time period. So because we're working with a time period, we're going to go and we actually have to do some subtraction here. So we're going to take the age of those living at 18. Remember, there's more people living at age 18. So we're going to take that as our beginning mark. And by looking at the chart, you find out it's 99,260. Now we're going to subtract from that the amount of people that died at age 50. So we've got to go over to where it's 50 and find the amount of dying. And, sorry, not dying. That's the number alive. Sorry, number of alive. Subtract them and we get 4,960. Okay? That's telling us how many people died between there. So these are your amounts of people living. Subtract the difference to find who actually died. Now we're going to take that and put it all over the amount of people that are living at age 18, which if you notice, it's the same number. Divide top by the bottom and you get 0.0495. We're going to go ahead. We're talking about percents now. Move it 2 to the right and we get 4.95%. So that is the percent of death of those between age 18 and 50 dying. Now, the last part says out of the 1,000 people, how many men? So they want the actual number. So just like we did in the other example, we're going to take our percent, turn it back to our decimal, and multiply it by the 1,000. So we know within that time period between age 18 and 50, 50 men will die. Okay? And that's how we go ahead and use the table to find the amount. This is what our insurance companies are doing to help them determine how to set the premiums for the insurance. Okay? Now, remember at the last column there, it talks about expectancy years. How many years to expect to live? And so this last example working with our table says use the life expectancy information from 12.1 to determine the expected age of death for a 17-year-old man and a 62-year-old man. So what we're going to do is first go ahead into our 17-year-old man. Okay, he's 17. Now we're going to go to the chart. We're at age 17, follow it all the way across. And underneath the column saying expectancy years, you see 61. So this 17-year-old, on average, will live about 61 more years. And we're going to add them up, and we'll find that average age of death is around 78 years old for a 17-year-old man. Now, it asks us how about for a 62-year-old man? We're going to do the same thing. We're going to take his average age here, his 62. And we're going to take the chart, follow it all over for a 62-year-old man, and we'll see that there's 19 more years he can expect to live. Add them together, and on average, he's got about 81 years of life. Remember, only God knows when you're going to die. Okay, this is just average by looking at collective data. Okay, so now that's how we work with our table. We're dealing with life insurance, though. So now we actually need to look at the insurance part of it. So how much insurance should a person purchase? And to do that, we've got to decide on what is the function of insurance. The function for life insurance is to compensate for the economic loss to a family when the wage earner dies. That's what life insurance is for. It's not just to have extra cash to have fun. It's making sure that your family is covered. So if you only have the man who's providing the income, they tend to take out a larger insurance life insurance for him because he's the provider. Okay, if both husband and wife are working, they then take out to make sure that there's enough to cover for both of these wage earners. Okay, so here we go. When we choose a policy, we need to make sure that it's taking out all debts and mortgages, that we're paying attention to it, okay? Because those debts and mortgages still have to be paid when the wage earner dies. So we have to add up all our debts and figure out how much needs to be covered. We also need to make sure that we can be able to cover funeral expenses and then to be able to invest some money that we can have income coming in to cover for that wage earner who died. So those are the three things that we have to consider when we're looking at the amount of insurance. Okay, now the monthly income especially for the investment part of it depends on the size of the family and how much the wage earner will be able to support. Now remember, if we had a husband and wife who are both working, that wife, if the husband dies, will still be able to bring in her income too. Okay, so not necessarily do they have to have as much money invested to cover living expenses if both of them are working. Where if it was just the husband working and the mom was staying home with young children or something, they're going to need to make sure that they have more money to be able to invest to give a larger income coming in to support the family. Okay, so let's take a look at examples and see how this works. It is a long example that gives a lot of information here, okay? So this wage earner is getting insurance. He has $45,000 for his mortgage still left. He wishes to have the mortgage paid off and leave his family with extra $8,000 to cover for funeral, okay, and other miscellaneous expenses. And normally they say an average funeral now is anywhere from $8,000 to $10,000, okay? So that's quite expensive. So you want to be able to make sure your family can cover that and not be left with those expenses, okay? He also wants to provide $2,000 per month for 25 years above the other spouse's income. So we assume the money can be invested at 8% and paid out by month to the nearest thousand. What size policy should he buy? Okay, that's a lot of information here. So let's break it down. What do I first need to stop and think about? First thing I need to think about is what is his immediate expenses? Okay, the first immediate expenses, his mortgage, and then the funeral expenses. So I'm going to add those together and I find out that his immediate costs are $53,000 for the mortgage and the funeral. Okay, now we're going to tackle all of this with making sure we have $2,000 per month and all this, okay? To work with this, I'm going to go ahead and reveal all of this. Remember this equation that we learned that I said will not go away throughout the rest of this book? This is investment, okay? This is our equation, how much total output. This is our per month expense. And then we have, remember, our I, that's taking our interest rate, dividing it by the 12. And N is the number of payments. So we're going to go ahead, use this equation, put the information from our problem. We know we're investing it at 8%. So we're going to take, to find our I, we take the 8%, divided it by 12 because it's being paid out per month. We find out we get our I is 0.006 repeating. Now N. Remember, in our problem, they said it wanted this to happen for 25 years. Okay, so for 25 years times every month, we get a total of 300 payments. Okay, now that we know our I and N, we're going to go ahead and put this into our equation. Our R is what this person wanted, and he said he wanted to have $2,000 per month. So we're going to put that in place for R. Put the rest of the information in for I and N. Use our calculators to continue to do the math. And when we do that, we find out, we're going to round it to the nearest thousand because that's what the problem told us. And we find that we need to have $259,000 to invest to make sure that this portion of the problem can happen, that the spouse will get $2,000 per month. Okay, now we're going to take that money for investing and add it to our immediate needs that we found up here in step 1. And that tells the person that he needs to have an insurance policy of $312,000 to be able to meet everything that he wants in this problem. Okay? Now, there's a thing called the broker's rule of thumb. And the broker's rule of thumb says that when you're considering buying insurance, you want to make sure you carry enough life insurance that equals about half the number of years until you reach age 60. Okay? You're going to take that number of years and multiply it by the owner's annual salary. Okay, so let's actually put this into practice and see how that works. Okay? Excuse me. So here we have our example. Find the amount of coverage a 38-year-old person who earns $42,000 a year should carry. Okay, so the first thing we're going to go ahead and do is find out how much years he has left. Okay, so remember our broker's rule says 60, and we want to find the difference between the age, and they said it's 38. So 60 minus 38 is 22, and then we want to take half of it. So we're going to take 11 years, and then we're going to multiply it by the person's salary. And up here we find that his salary, annual salary here is $42,000. Multiply it together, and we know we need a $462,000 policy. Okay, now let's actually start looking at the book assignments. So that's all the examples our book gives us. Now, how will we apply it in our homework assignment? Simply, it's looking through and understanding what all these terms mean. So starting off right at problem number 1 in your book, it's just asking, what does L25 mean? Okay, and remember, L means our living, and 25 means the year. So what does that mean? Simply, how many are living at age 25? That's all that means. It's abbreviation for that. Okay, going down to the next section, problem number 4 asks us to use the mortality table to find the following for a population of 100,000 men. And problem 4 says L55. So what we're going to do is use our table on page 447. We're going to go to where it shows a 55-year-old man. And you're going to go then to where the column says L. And you're going to find that it says 92,220. That's all they're asking. They're not asking for you to do multiplication. They just want you to read your chart. Okay, problem number 10. This is now when we get into using our equation and our probability equation here. Remember, it's reading the problem, we have to be careful. Are they asking for the living or are they asking for the death? And looking at problem 10 is asking for the living. Okay, so we're going to find out how many people are actually living at age 25, because it says age 25. And then if you look in the instruction, it talks about for an 18-year-old man. So in our denominator, we're going to look at the age for those that are 18. Find the numbers in your chart. By age 25, go to where it says L, you'll get that number. Look at 18, and you'll get that number. Take the top divided by the bottom, and you get 0.993. Move it to the right to deal with the decimal, and you get 99.3%. Okay. Now, 14 is like the other example we had. Okay, they want to know how many people are going to die between these age 20 and 52. Okay, so I need to find the number that are actually living at age 20, and subtract those that are living at age 52. Find that difference, and that tells me how many people are going to die. Now, in the denominator, I'm looking at starting at age 20, and that is the number. Remember, they're going to be the same. Take your top, divided by your bottom, move your decimal 2 to the right to get your percent, and it would be 5.5. Okay, now we're not done though. Remember, because it's asking us for the amount of people out of a group of 1,000. So we want to know actual numbers. So I'm going to take my percent, put it back in decimal form, multiply it by my 1,000 people in my study, and I find out that 55 people will actually die. So be careful. Watch what they're asking for. Problems 14 through 17 are all asking for the amount of people who will die. Okay, last one here, starting in this section, it's asking us to find actual amounts for life insurance here. Okay, now problem number 18 and on, you've got to be careful. Is it giving you information for per month or per year? Problem 18 I'm doing here because this one's a little different. Your notes show you per year. Problem 18 says per month. So the very first step I needed to do is it told me 2,850 per month was what the person got. So I need to go ahead and multiply it by 12 to get it to per year. Okay, so that's my annual salary. Now I need to find out how much I need to multiply by that. So using the broker's rule, I need to find the difference between 60 and 38, which I get 22 like we did in our problem, divide it by 2 because it says half, and I get 11 years. Now I'm going to go ahead and take that 11, multiply it by 34,200, and I get this using my broker's fee. Now it says, careful, it says round to the nearest thousandths. So I'm going to go ahead, 200 is less than 500, so I'm going to round it down to $376,000 is what this person needs for mortgage. I'm sorry, not mortgage, but for their life insurance policy. Okay, so these examples hopefully will help you be able to move on through this section. If you got any questions, continue to text me or email me.